Guys, we're going to jump into our lesson for 6.3, and we're dealing with bar model diagrams. And our I can statement, guys, is to be able to use bar models to solve equations. You guys know we've used trial and error we've looked at, and now we're going to look at a different strategy called bar models that help us solve. These work really well when there's multiplying and dividing, multiplying and adding. It gets a little tougher to use this bar model diagram when there's subtraction and division in there. So we'll just take a look at a couple examples here, and then you'll get a lot of chances to practice, because this takes a little bit of practice and time to see what's going on. So I'm going to model it with this first one, 3d plus 12 equals 20 plus d. Okay, and if you look above at the example, notice they're making bars that are equal to each other. Okay, that's an example you can study on your own too after this. But right now I'm going to kind of go from the process and how I start when I see a problem. Again, I notice there's multiplying and adding, so this bar model strategy is a good one. The first thing you do is make the two bars equal to each other, because these two sides are supposed to be equal. All right, so this side equals this side. So one bar is going to be this side, and the other bar is going to be this side, and they're equal sized bars. Okay, so you kind of got to look, and if you can make the sizes close to normal, that's what you want. So for example here, see how this has 1D and this has 3Ds? So 3D should obviously look a little bit more than 1D because there's three of them. Okay, so this first one I'm going to put 3D, and I'll probably go to about here, and then plus 12. And that's the top. That's the whole bar. It's 3D plus 12 more to get that whole bar. And then this is 20 plus D. And one thing you'll learn is you want to kind of put the D's underneath each other. So 1D would be obviously less than 3D, so I'll make it about there. And this whole thing has to be 20. D plus 20 equals 3Ds plus 12. Their bars are exactly the same size. Okay, so this is the first step in the bar model, to get it in there and try to get the sizes similar. And it won't always work out perfectly with the sizes, okay? But notice I put the D's and the D's underneath each other. If I wouldn't have, I would have to flip them around at some point when I'm making these boxes, okay, in these bar models. So I'm going to go ahead and I'm going to break it up a little differently. Again, I'm going to make my bars again, but instead of 3 D's, let's do 3 individual D's. Okay, so I've got 3 individual D's, and the reason I'm doing that is because I had 1D down here. You want to get everything to equal on top. And sorry, that's drawn right in the light, so I'll redraw that here. I just noticed. Kind of a pain with that light. Okay, so if we look in here now, the 3D plus 12, I'm going to put the 3Ds separately. And then I'm going to line up that 1D, because they equal the same amount. D always equals D. And our job is to try to get everything on top to equal everything on the bottom. So this was 3D plus 12. So that's still 12. And if I know that much is 12, then down here I can also break that up. I know that equals 12. They're the same amount. Now the whole bottom is supposed to equal 20. So if I take 20 minus that 12, I know that leaves me with 8. So now it's still 3D plus 12, and this is still D plus 20. I just broke it up differently. But what I'm doing is trying to get everything to equal something on top, and then I can cross it out. I like, well, D equals D, so they're the same. They're equal, because both sides we need to get to equal each other. And 12 equals 12, so those two are equal. So really what I'm left here is 2 D's that have to equal 8, and then when you get it broken down to that far, you guys can easily, and again, you could rewrite it or you wouldn't have to here, but for these 2 D's to equal 8, I know that they would each have to equal 4. So I could cross them out and say D has to equal 4. Because 2 D's equal 8, so 1 D has to equal 4. So you can kind of look at it like that. And you know, to make this true, again, if D equals 4, I can substitute in and go back to the original if I need to, either on here or up here. But we say D equals 4. Let's check it out. 3 times 4 is 12. Plus 12, and I plug it in over here. D is 4. 20 plus 4 is 24. Well, 12 plus 12 does equal 24. Okay, so both sides are equal when D equals 4. So I've solved that D equals 4. And I didn't use trial and error. Okay, I used this bar model strategy. And some of these can look a little different when you make them, because you could put the D's on the other side. You could flip them because of the commutative property. But your whole goal is to get it lined up, so you get it broken down and find out what 1D in this case, has to equal. So there's one example. This works really well when there's variables on both sides. See how there's a D on both sides? So this strategy works well, again, when there's addition and multiplying and dealing with it. But there's another example here we'll look at that can be a little bit different. Make sure you have this copied. Pause the video if you need to. All right, so if we go down to look at number 4 here, this time we don't have a variable on each side. That's okay. Again, we're going to make a bar model. And we know that the bars need to be the same size because they're equal. And guys, it doesn't matter which side you put on the bar. If you put on the top or the bottom bar, it doesn't matter. But I'll just go the way they have it. 86 is here, so I'll put that on top. The whole thing is 86. And that has to equal 14 plus 3b's. 14 plus 3b's is the same length bar as 86. All right, so let's start to break this up a little bit. And in this case, I know this is 14 from here to here. So this is also 14. They have to equal the same amount. Well, I know the whole thing was 86. Well, I've already used 14, so let's take 86 and take away 14. And I get 72 left. Okay, I've got 72 plus 14 equals 86, so I haven't changed anything. And down here I have 3 b's. Again, we like to kind of look at them as individual b's then in this case. And I have 3 b's equals 72. I can cross out the 14s. They equal each other. They're balanced. They're equal. So 3 b's equals 17. Our goal is to find out what 1 b is, so I can just take this 72 and divide it into 3 parts. Okay, so 72 divided by 3. And I get 24. Again, I'll just write it down below here. 24, 24, and 24 is 72, so I know b equals 24. Again, I could go plug it in here to make sure. Do my substitution. 24 times 3 is 72. I multiply first when I do my PEMDAS in order of operations. So I'm left with, this is 72 plus 14 has to equal 86. And I know 72 plus 14 is 86. So I know my answer is correct. And we plug it in. If it works, when I substitute it in, then I know I'm right. So these bar models can look a lot different. It takes a little bit of time and practice, but they're just a couple of examples. Again, good reminder for you is that if there's a variable on each side, these are good to use. If there's addition and multiplying, and even if there's no variable on the other side, when it's adding and multiplying, these work pretty well. Okay. Again, we've got trial and error for a solving strategy, and now bar models, and we'll look at some other ways in the future also to be solving these algebra problems.